Okay, babies, for example 14, I'm going to let you read this because I'm not going to read it to you, but we are dealing with microcomputers, and the title of this is My Technology's Broken. Sounds familiar. All right, so the microcomputers are going to come from either factory A, B, or C, and we know that factory A produces about 15 defectives, B produces about 10% defectives, and C produces about 5% defectives. I also know that how many they produce is also important here. So I know that 40% come from factory C, 40% are from factory B, 20% are from factory A. All right, so this is your first example that's going to involve using a tree. How can you tell you're using a tree? Well, for this particular problem, you're given some conditionals. If it's from factory A, okay, that means 20% are produced in factory A. If it comes from A, I can expect about 15% of those microcomputers to be defective. All right, so these are problems in which you're given a conditional and you're asked for unions and intersections. So if you'll notice down here in the question, and that's an intersection, all right? So the first thing we're going to do is set up the tree. This is a strategy just like the Venn diagrams and the tables are strategies. So I am going to start first with where the microcomputers come from. Oh, dang it. I'm out of control. And how we're shocked. Okay, so if it comes from A, about 20% come from A, B, about 40%, and C, 40%. Now, depending on where they're from, that's how I can decide if they're defective or not, or how I know how many are defective or not. So defective for A is going to be 0.15, so that would mean not defective would be 0.85, because it's either defective or not, right? So those are all the outcomes. So for this one, defective and not defective, I did not give myself enough room for this problem. Grr. Okay, so defective from B is going to be, let's see, 0.1, and so 0.9 here. And then C, defective and not, so sorry, this is so sloppy, kids. C, defective 0.05 and 0.95. Now, how do we come up with probabilities? Well, you've got to finish out the tree, and the way you do that is just like this. You're going to multiply out. So 0.2 times 0.15 is 0.03. All right. 0.2 times 0.85 gives me 0.17. 0.4 times 0.1, of course, is 0.04. 0.4 times 0.9 is 0.36. 0.4 times 0.05 gives me 0.02. And 0.4 times 0.95 gives me 0.38. All right. So those are all of my possible probabilities here. So for part A, I'm asked, what is the probability of finding a defective microcomputer in this shipment? All right, so here's what you have to think about. When we're talking about defective, that means it comes from A and it's defective, or B and it's defective, or C and it's defective. Well, if you'll notice here on the problem, if it's from A and it's defective, that's 0.03. If it's B and it's defective, it's 0.04. If it's from C and it's defective, it's 0.02. So you guessed it, the probability, oops, that should be a P, not a B. The probability that I get a defective microcomputer in a certain shipment is 0.03 plus 0.04 plus 0.02. Magic. All right. The next question, B, are the events microcomputer comes from factory A, all right, so I know 20% come from factory A, and microcomputer comes from factory B, 40% come from factory B, are those mutually exclusive? All right, if you stop and think about this, I can't have a single computer that comes from both of these, all right? A single computer can't come from two places. So, from A and from B, are disjoint. So the answer is yes, all right, because mutually exclusive and disjoint mean the same thing. That's why I'm using both of the words here. So since I can't have a single computer coming from A and from B, that means that they are disjoint, or yes, they are mutually exclusive. So this is yes because they can't happen at the same time. In other words, the probability of A and B equals 0. There's no value for that. The probability doesn't equal anything. So because that is true, these would be disjoint or mutually exclusive. All right, part C. Are the events microcomputer comes from factory A and microcomputer comes from factory B independent? Well, think about this. The probability of A given it comes from B, is that equal to the probability of A if it doesn't come from B? Well, I want you to think about this because these events are disjoint. They can't be independent because remember, independence means that if it comes from factory A, it has no bearing on whether or not it comes from factory B. So because these are disjoint, they cannot be independent, okay? They can't be independent because we just discovered they are disjoint. Yeah, baby. All right? And keep in mind, since it can't come from factory A, if it comes from factory B and vice versa, this has no value. All right? It can't come from A given it comes from B. Also keep that in mind. You can look at it mathematically and you can look at it practically in definitions about these two things. All right, so part D. Suppose the manager randomly selects one microcomputer and discovers that it is defective. What is the probability that it came from factory A? Okay, you have to be so careful with this. Suppose the manager randomly selects one microcomputer and discovers that it is defective. So if it is defective, what's the probability it came from factory A? So I have to set this up like this. The probability it came from A if it is defective. Conditional probability. All right, babies, if it is defective, this is where things get tricky. I know it's defective. So that means it came from A or B or C. Well, remember what we did in part A. What's the probability of finding a defective microcomputer? That's the value right there that goes in my denominator. I know it's defective, so what's the probability it came from A? So 0.09 goes in the denominator, 0.03 goes up here. Now, kids, I know I told you to leave everything in fraction form, but it is not good math practice to leave decimals in your fractions. So we don't do that. We're going to go ahead and tidy this up. So we are going to divide 0.03 by 0.09, and you know what it is because, okay, this is good math practice right here. All right? Okay, so let's talk about something. The probability that it's defective, remember, is these three things added together, the 0.09. All right, when you're finding conditional probability with a tree, the denominator is going to be these things added up. The numerator will always be one of them, depending on what you're being asked. If I had asked you what the probability is it came from factory B, it would be 0.04 over 0.09. If I ask you about C, it'd be 0.02 over 0.09. So that is always how conditional probability works with a tree.